Chapter 3, Lesson 4, Compare and Order Rational Numbers. Our learning objective is that you will use number lines to compare and order rational numbers. Connect. You have used the number line to compare and order integers. You can also use a number line to compare and order rational numbers, including decimals and fractions. Unlock the problem. The table shows the average December temperatures in 5 U.S. cities. Which city has the greater average December temperature, Indianapolis or Boise? One way is to use a number line. You can graph the temperatures for Indianapolis and Boise. Think. As you move to the right on the horizontal number line, the numbers become greater. So we're going to graph the temperatures for Indianapolis, which is -6/10 for average December temperatures. So 6/10 is between 0 and 1, but -6/10 is going to be between 0 and -1. 1, 2, 3, 4, 5. So these are broken into fifths. So 6/10 is the same as 3/5. So I'm going to go from 0 and I'm going to go over 3 of the 5 integers to the left. And -6/10 is to the blank of -1, and that's to the right of -1. And we care about -1 because Boise is going to be -1, so it is going to go from 0 to the left to -1. Since -6/10 is to the right of -1, that means that the temperature that is the furthest to the right is Indianapolis, which is a greater average temperature. So remember that greater is to the right and less is to the left. Another way is to place value or to use place value to compare the decimals. So we can start with step 1. Write the December temperatures with their decimal lines or their decimal points lined up. So Indianapolis is -0 and 6/10. Boise is -1 and 0/10. Compare the digits in the ones place. If the number is negative, include a negative sign with the digit. So think 0 is greater than -1. So -6/10 is greater than -1. So here we look at just the ones value. 0 is greater than -1. So that would make that one a larger number. So step 2 would be to compare the digits in the ones place. Oh yeah, including the negative sign with the digit, so that we already did that. So -6/10 is warmer than -1, so Indianapolis has a greater average December temperature than Boise. So it's kind of the opposite. Well, it is the opposite of what it would be in positive. So positive numbers, 1 is greater than 6/10. So when you're negative, that 1 is further away from the 0 to the left, which makes it less. So let's look at the examples. Example 1 says the elevations of objects found at a dig site are recorded in the table. Which object was found at a lower elevation? The fossil of the shell or the fossil of the fish? One way is to use a number line. Graph the elevations for the fossil of the shell and the fossil of the fish. So we need to be thinking that as you move down on a vertical number line, the numbers become less. So we're going to go ahead and graph the elevations. So shell is -3 1/2. So I'm going to start at 0, go down to 3. 3 1/2 is going to be halfway between 3 and 4. And then fern is 1/4, which is positive. So 0, between 0 and 1, I'm going to go up 1 of the 4. Fish, -3 1/4. So 0 to -3, and then only 1/4. So fish is -3 and 1/4. Shell is -3.5, and fern is 1/4. So there we go. So looking at this, -3 1/2 is below -3 1/4 on the number line, which would make that one the lowest. So another way is to use common denominators to compare fractions. This is something we have done before. So write the elevations with a common denominator. So if we take -3 1/2 and turn it into fourths, to get 2 to 4, you have to times it by 2. So you got to do the same thing to the top. So -3 1/2 can turn into -3 2/4. -3 1/4 minus, or -3 1/4 stays as -3 1/4. And since the whole numbers are the same, you need to compare the fractions. So -2/4 is less than -1/4. So -1/2 is less than -1/4, because again, it's further away from 0 to the left. So the fossil of the shell was found at a lower elevation than the fossil of the fish. Example 2, you can compare -1/10 and -4/5. Convert all fractions, or convert to all fractions or decimals. Again, we've done this before. So if I were to convert the fractions into, or just convert to fractions, so I would take -1/10 and just write it as it sounds. I'm going to take -1/10. -4/5, if we turn that into tenths, to get fifths to tenths, we have to multiply the top and the bottom by 2. 5 times 2 is 10. 4 times 2 is 8. So now -8 is less than -1. So -4/5 is less than -1/10. You can use a number line to check your answer. So if I have here 0 and -1, -4/5 is further to the left than -1/10. Or you could use decimals. So we have -1/10 equals -1/10. We don't change those. The -4/5 turned into tenths is 8/10, we said, which is just 0.8. -8/10 is less than -1/10, so -4/5 is less than -1/10. Okay, it's a whole lot of talk, but if you just break it down to the basics, what is it asking me? This is all stuff that you guys have done before. We're just combining it into a single problem now. So that was lesson 3.4, and our objective was that you will use number lines to compare and order rational numbers. If you have any questions, please ask your teacher.